This lesson is about writing equations of parallel and perpendicular lines, and so here is the big key point you need to take away. Parallel lines will always have the same slope. So if you want to prove that two lines are parallel, you got to show that they have the same slope and a different y-intercept. So anytime we see a slope, for example, if the slope is 3, then any line that's parallel to that is all going to have a slope of 3. And the other big takeaway from this is that perpendicular lines have slopes that are called opposite reciprocal. So what this means is for example, if a line has a slope of 2, like let's say 2x plus 1, then a parallel slope is also going to be 2. But a perpendicular slope is going to be the opposite reciprocal. A perpendicular slope, a perpendicular opposite reciprocal of 2 would be 1/2, and it would be negative. So the perpendicular slope to this line would have a negative. It would be like negative 1/2 x plus something. If an equation had a line, for example, of negative 2/3 x plus 4, then a parallel slope is going to be the exact same as this number right here. So a parallel slope will still be negative 2/3, but a perpendicular slope is the opposite reciprocal. So you flip the fraction 3/2 and you make it positive. So a positive 3/2 would be a perpendicular slope to this line. That's going to be really important going forward. So we're being asked to graph a couple of equations and then we're going to compare them. The question is asking us, what do we notice about the graphs of these two lines? So we're going to start by graphing y equals 2x minus 3, and I notice that it's got a slope of 2 and it's got a y-intercept at negative 3. So we're going to go ahead and draw this graph. We'll start by going down 3, there's the y-intercept, and then the slope is 2, positive 2, so it's going to go up to the right, and we're going to finish graphing this line. And there is our equation of y equals 2x minus 3, even though I didn't draw that terribly straight. It is what it is. And then I'm going to take this equation, and we've got to do a little bit of work. First, we have to distribute the 2 before we can graph it. So if I distribute the 2, that'll be y equals 2x plus 2, and it's got a y-intercept at 2. So we'll start by going up 2, and then it's still got a slope of 2/1. So from here, I'll go up 2/1. I'm going to go down 2/1, put a couple other dots on there, and then I sketch my squiggly, sort of not straight, but kind of straight line. And if you use a ruler on your paper, you'll notice that these two lines are parallel. They have the exact same slope. This one had a slope of 2, this one had a slope of 2. I'll let you answer question B. But these two lines are parallel because they have the same slope, and the slope is 2. Now in this example, we're looking at two different lines. These are already graphed for us. Here's this one is already solved in slope-intercept form, 3x minus 14. It's got a positive 3 slope, and you can see that this line has a rise of 3/1. It looks like it's headed down towards a negative 14. So that's this line right here, y equals 3x minus 14. And then this line here is the other one. And just to convince you, if we take x plus 3y equals 22, if I want to solve that for y and get it in slope-intercept form, we're going to take this last equation. We're going to divide this by 3. And 3 goes into 22, 7 1/3 times. And that right there is 7 1/3. There's your y-intercept. It's got a negative 1/3 slope. And there you go. We have these two lines. Now, this question is asking you to get a protractor, and I don't know that you need to use a protractor, but this right here is a 90-degree angle. And that means that these two lines are perpendicular to each other. The lines are perpendicular. They intersect at 90 degrees. Take a look at their slopes. The slope of one line is negative 1/3, and the slope of the other line is 3. So the 3 and the negative 1/3 are perpendicular slopes because they are what we will call opposite reciprocal of each other. And here's what that really means. If you take the slope of this line here, which is 3 over 1, and you take the slope of the other line, which is negative 1/3, and you multiply them together, the 3's will cross off, and you're going to get an answer of negative 1. So if two non-vertical lines are parallel, their slopes are going to be the same. They'll be equal. But if two non-vertical lines are perpendicular, the product of their slopes is negative 1. Okay, we're going to get into the meat of this lesson here, and that is to be able to write an equation of a parallel line or a perpendicular line. So we're going to write an equation in slope-intercept form. So we want to have it be in y equals mx plus b form. So I need to find the slope and I need to find the y-intercept. And here's our first problem. We have a line, y equals 5x plus 1, and we want a parallel line. Parallel lines have the same slope. So the slope is going to be 5. So there's our slope, but it has to pass through this point, negative 1, comma 2. Now, negative 1 is our x and 2 is our y, and you're going to have to use, there's two ways to do this. The fastest way probably is just to use point slope, which is y minus y1 equals m times x minus x1, and we're going to go ahead and plug it in. Y minus 2 equals 5 times x. Now it's minus a negative 1, so I'm just going to write plus 1 because it's going to be the opposite of what we see here. And then we just get, we're going to use the distributive property, y minus 2 equals 5x plus 5, and then we'll add 2 to both sides and be done. And so the equation of the line will be y equals 5x plus 7. That line is parallel to y equals 5x plus 1, but it passes through this point. And so that right there is our line. This problem really isn't any different than the last one. We're going to write a line. It's going to be parallel, so that means we're going to have the same slope. And so we need to look at the equation. Identify the slope of that line. The slope is negative 3. So there's our slope, and then here's the point that we need it to pass through. We need it to pass through 9, comma, negative 6. So we'll go ahead and go back right to point slope form. Y minus y1 equals m times x minus x1. And you know what? I think I'm actually going to try and do this one a little bit differently. Let's go ahead and use slope-intercept form. Let's use y equals mx plus b. I already showed you how to use this top one once, so let's try this one. We're going to plug in, there's m, there's x, there's y, and we're going to go find b. And you can do this either way. Y is a negative 6, m is negative 3, x is 9, and then plus b. So negative 6 equals negative 27 plus b, and if I want to solve for b, I'll add 27 to both sides, and I'm going to get 21. B equals 21. I already had my slope. M was negative 3. B was 21, and so the equation for the line is y equals negative 3x plus 21. If you use point slope form, you're going to get the same answer. We've written a couple of equations that dealt with parallel lines, so let's focus for a minute on perpendicular lines. So perpendicular slopes are opposite reciprocals. So I want you to think about these two questions. One is, what's the slope of the line that we're looking at? And the slope of the line is 1/2. And now I want you to take that fraction, we're going to flip it, we're going to make it a reciprocal. So the reciprocal of this will be 2 over 1, and now opposite, we're going to change the sign. Well, this is positive, so this one's going to be negative. And the reason that we know these two slopes will be perpendicular is because when I multiply them together, their product is going to be negative 1. So when I multiply 1/2 times negative 2, the 2's cross off, they become 1, and all I'm left with is a negative 1. So that tells me that these are perpendicular slopes. So this is the slope right here that I'm going to use when I go to write the equation for this line. So my slope is negative 2. I'm not going to put the fraction. And it's going to pass through this point, 1, 5. And then we're going to go right back to, I'll use point slope this time, y minus y1 equals m times x minus x1, and then we're just going to go ahead and plug those in. There's x and there's y. So it's going to say y minus 5 equals negative 2, that's our slope, our perpendicular slope, times x minus 1. We'll go ahead and use distributive property on the negative 2, negative 2x plus 2, and then we will add a 5, and we're going to end up with y equals negative 2x plus 7. And you can take a look at the slope that we have here, which is a negative 2, is perpendicular to a slope of positive 1/2. And that is the equation of the perpendicular line. We're going to write one more equation for a perpendicular line. This time we're looking at kind of a gnarly function, and we're going to look at the slope. So the slope on this particular line is negative 2/5. And so here we're looking at a slope that's already a fraction and it's also negative. So the perpendicular slope, that upside down t is for perpendicular, the perpendicular slope to this equation, to this slope, flip the fraction. So now we're going to get 5/2 and make it opposite. So this one is negative, so this one's going to be positive. So we're going to use 5/2. So m is 5/2. And we're still going to go through this point. So we got a couple of negative coordinates, negative 6, comma, negative 8. And again, there's our x, there's our y, and we go right to the equation. Y minus y1 equals m times x minus x1. Point slope, and we're going to get y plus 8 equals, we're going to use our perpendicular slope here, 5/2 times x plus 6. Now, to be done, let's distribute the 5/2 to both of those. So that's 5/2 x, which isn't going to be a big deal. And then we're going to multiply 5/2 times 6. So if you're not sure how that works, the 2 crosses off with the 6, and that reduces to a 3, and that becomes 15. So plus 15. You can also look at it as 6 times 5 is 30, and 30 divided by 2 is 15. And then to wrap this problem up, we'll take away an 8 on both sides and we're done. So we end up with y equals 5/2 x plus 7. And that is a perpendicular line to this equation here that also passes through the point negative 6, negative 8.